Welcome back, students. In this video, we're going to cover Module 8, Topic 1, Dilations. This is, of course, page 1 of the Module 8 packet. I'm going to start here momentarily with the warm-up. Okay. All right, so it says write each fraction in simplest form. So we're going to take this back to 3rd grade, I believe, with fractions. If you guys need some brushing up on greatest common factor, I recommend you look for a Google video. I don't really have time to teach that in this video, but we will need to be able to kind of break down fractions because we're going to be dealing with ratios or fractions, and we need to be able to break big numbers down into smaller numbers when necessary. So I don't have any magic formula. I'm just gonna, I'll try to throw things at you as I can. But so let's start with the warm up. We're gonna write each fraction in simplest form. Number 1 is 15 over 81. Good rule of thumb. Start with 2. These are both odd numbers, so 3 is likely going to work. 3 goes into 15 5 times. 3 goes into 81 27 times. Let's see, 5 won't go into 27, so that's going to be as far as you can break it down. Number 2, 36 over 216. So they're both even, so 2 would work. They both end in 6. We could try 6. I think we could go bigger though. Just happen to know that 36 is a multiple of 216. So let's try 36. 36 goes into 36 one time, and 36 goes into 216 6 times. All right, number 3. 95 over 240. So I know with 5s, I always look for 5 or 0, so we know we can use 5. So we can use 5 because 5 goes into 95 19 times, and it goes into 240 48 times. Let me go back here. So our greatest common factor under here was 3. I'm just going to circle that. 36 here, 5 here, just so you guys know. Okay. All right, number 4. So we got 51 over 540, so an odd and an even. So we're going to try 3. 3 goes into, so let's just put 3 and circle it. 3 goes into 51 17 times, and it goes into 540 180 times. And those won't break down any further. And on the end, number 5, we got 189 and 300. Any 9 right there is a multiple of 3. Obviously 300 is, so let's just try 3. 3 goes into 189 63 times, and it goes into 300 100 times. That's not going to break down any further either. Okay, so we're going to scoot down the page. We got some notes. So non-rigid transformations. So recall that rigid transformation is an operation that maps an original figure, the pre-image, onto a new figure called the image. So let's say original pre-image. Just gonna, and then let's do here. The new is the image. So we've talked about this before, but I want to drive this point home because you guys really, if you don't know the difference in pre-image and image, it's really going to be difficult to pass the EOC. So I want to drive that point home. All right, so a non-rigid transformation is a transformation that changes the dimensions of a given figure. A dilation is a non-rigid transformation that enlarges or reduces a geometric figure. When a figure is enlarged or reduced, the sides of the image are proportional to the sides of the original figure. So, original, let's see. So, original or pre-image. The new is the image. Another thing I want you guys to notice. So if we started out with A on our image, our pre-image, excuse me. Let's see if I got an orange, yeah. When we change, or when we dilate in this case, the image, the new figure is A prime. The old figure was A. It's B prime, C prime. It's the same for the others. So let's scooch down a little so we can see. All right, so the center of dilation is the center point from which dilations are performed. The scale factor of a dilation is the ratio of the length on an image to the corresponding length on the pre-image. The letter K usually represents the scale factor of the dilation. Let's see. The value of K determines whether the dilation is an enlargement or a reduction. A dilation with a scale factor greater than 1 produces an enlargement. Hold on. So scale factor greater than 1 produces an enlargement. Running out of different colors here. Because I have no yellow. Kids got a hold of those. All right, and a dilation scale factor of between 0 and 1 produces a reduction, or an image that is smaller than its original figure. So, if it's greater than 1, it's an enlargement. If it's between 0 and 1, it's a reduction. Obviously, numbers between 0 and 1 are either going to be fractions, or, they could be decimals. So, let's scooch down here. Do our practice. All right, so number 1. Determine whether the dilation from ABC, and 2, just going to keep the same color going here, DEF, is an enlargement or a reduction. Then find the scale factor for the dilation. All right, so first thing we're going to find, so we got to find the corresponding sides. So AB and DE. See, A, B, C, D, E, F. A, B, C, D, E, F. And we've talked about corresponding sides, corresponding angles before, but again, trying to drive the point home. Now, to come up with our scale factor, or our K, it's always going to be new over old. So this is the, let me change colors here. So this guy's new, this is the old, because it says from ABC to DEF, from to. So our from is our old, our 2 is our new, but when we put these in our fraction, so K equals the new, that's 2 over 6. 2 over 6, so 2 goes into 2 one time, 2 goes into 6 3 times. So is this an enlargement or a reduction? Well, it looks smaller to me. So it's a reduction. And obviously, we know, again, because it's a fraction, not a whole number. If it's greater than 1, it's an enlargement. It's 0, between 0 and 1, it's a reduction. And you can tell by looking at it. All right, number 2. Determine whether the dilation of from, so we're going to keep the same color scheme here, from ABCD, so from ABCD, I'm just going to put that there because that's, I'm going to have to zoom in to see the number here. Jeez. Okay, and 2 LMNP. So this is the from, or the old. This is the 2, or the new. That's 18. And that is 6. 6 goes into 18 3 times. It goes into itself 1 time. So our scale factor is 3. It's greater than 1, so it is a enlargement, and obviously that's bigger than that. Okay, flip over to page 2. Top of the page, number 3. This is page 2. Excuse me. Number 3, school spirit. Jalal is printing a banner for his school's wheelchair tennis team based on the design shown below. By what percent should Jalal enlarge his design so the dimensions of the banner are 5 times that of the original design? All right, so important info here. 5 times. So original is 6 by 14. So 6 and 14. If it's 5 times, it's 6 times 5, 14 times 5. 6 times 5 is 30. 14 times 5 is 70. So the new dimensions will be 30 by 70 inches because we enlarged it by 5. Okay, let's see. Dilation centered at the origin. So now we're going to talk about the coordinate plane. On the coordinate plane, a dilation is a function that involves multiplying a scale factor of k to find the coordinates of the vertices of an image. So our x comma y is going to be kx, ky, or k times x, k times y. That's how we're going to get to this. So sticking with the same color scheme, in this example, PQR is becoming P prime, Q prime, R prime. So notice that's how we tell. Also, when it doesn't tell us, it's the prime. Hopefully you guys can see it on your paper, even if you can't see it in the video. Let me scooch this. All right, so the image of PQR, so this guy, is dilated k equals 3 to get P prime, Q prime, R prime. So notice if you say 1, this is over 1 and up 1, 2. That's over, let's see. Oh, no, we're not doing that. We're going by size. And anyway, so the orange one is 3 times bigger than the green, or P prime, Q prime, R prime is 3 times the size of PQR. All right, so let's go down here and go to number 4. I'm going to just scoot this so I know I have a little room. All right, number 4. So we don't need the coordinate plane. We don't have to graph some of these things. So like number 4 and 5 here, we're not going to have to graph. We're actually going to graph them down here. I'll try to keep the colors coordinated or best we can. Okay. Triangle TRS has vertices. So let's see. T is -4, -5. R is 0, 6, and S is 4, 3. All right. Find the coordinates of the vertices after of T prime, R prime, S prime after a dilation of TRS centered at the origin. So when we're centering things at the origin, of course you can't see where I'm pointing, but we don't have to mess with anything. We just multiply x by k, y by k. Let's just write this. So x comma y is kx comma ky. So T prime, so -4 times 1/2, that's 4 over 2, -4 over 2, which is -2, and then -5 times 1/2, half of -5 is -2.5. All right, R prime, multiply anything by 0 and you've still got 0. And then half of 6 is 3. S prime, half of 4 is 2. Half of 3 is 1.5. So let's see. We were going to make our green our starting point. So -4, -5. So that's T. R is 0, +6. And then S is 4, +3. Let's see if I can find my compass. Let's see. No ruler, no nothing. This is what happens when you have little children. If any of you with little siblings understand what I'm going through. Alright, so I'm not going to be perfect because I didn't use a ruler or a compass, but so TRS. Excuse me. So now, -2, -1, 2.5. All right, let's see. R, 0, +3, and then +2, and this is 1.5. See, it's on that line. So down here, here. All right, see, let me try to color this in. This highlighter may be a bit much, but let's see. A little bit of the color in here. Mr. Whitlock pretending to be Bob Ross here or something. All right, so our image where we started was TRS. Our pre-image where we started was TRS. Our image, looking at that and talking about the wrong one, is T prime, R prime, S prime. I'm just gonna, you can see R prime in there, but so we basically are half the size after that's said and done. Okay, scooch over here. There we go. Number 5. All right, X, Y, Z. Say X is 3, -1. Y is 2, 2. And Z is -3, -2. So again, X, Y is KX, KY. So this one we are multiplying by 3 because so it's going to be an enlargement because it's greater than 1, excuse me. All right, so X prime, so 3 times 3 is 9. -1 times 3 is -3. Y, so 2 times 3 is 6. 2 times 3 is 6. Z prime, -3 times 3 is -9. -2 times 3 is -6. So let's see what we got here. So X is 3, -1, 2, 2. So this is X, this is Y. And then Z is -3, -2. Probably not going to be able to see because we'll see. All right, so X prime is 9, -3. 1, 2. Y prime was 6, +6. And Z is -9, -6. Again, no straight edge to do this the right way. So it's not going to be exactly perfect, but okay. So see, on the left we shrunk in half, and on the right we expanded 3 times. Okay. Excuse me. Okay, number 3. I'm sorry, page 3. Excuse me. Good grief. Dilation with other center points. So things are going to get a little more complicated here. So a figure will not always be dilated with respect to the origin. A center of dilation can be any point on the coordinate plane, including a point on the figure. So in this class, we're going to keep it fairly simple. It's usually going to be one of the 3 vertices. I mean, they could actually do this random point inside the figure, but that would be way complicated math. So we're just going to stick with one of the vertices here. So our key concept, dilation centered at a point that is not the origin. So dilate a figure by a scale factor of k. So let's do this. Dilate a figure, scale factor of k with respect to the center of dilation. So remember previously we had, when we translated, we had a vector. It was AB. A being the x coordinate, B being the y. X being the horizontal, B being the vertical. So here the dilation, or center of dilation, is going to be that point AB, and we're going to translate each vertex along that. So it's going to go like this way. So let's do this. So we start out at DEF here at the little triangle. Notice D prime is the same as D, and that's because D is going to be the center of dilation. It's going to tell us over here. I hadn't got to that point. I'm getting ahead of myself, but sorry. So anyway, let me just draw this in here. There we go. Okay. All right, so yeah, let me just reread this. So to dilate a figure by a scale factor of k with respect to center of dilation, AB, translate each vertex along vector -a, -b, then multiply the x and y coordinate by the of each vertex by k. Lastly, translate each vertex along vector AB. So they said all that to say this. And sometimes I told you guys it gets a little hairy. So our xy in this case is going to become k. So it's a parentheses out here, k, times x, our x coordinate, minus a. So wherever our center of dilation is, we're going to subtract the x coordinate of that from our x. Plus, we're going to add the x coordinate back in. Then we're going to do the same thing with the y. K times x, y minus b. That's the y coordinate of our center of dilation, and then add it back in. It's not as bad as it sounds. So like over here, DEF's dilated by a half. So yeah, and I did it backwards. Dang it, I knew it was going to happen. So here, DEF, and here. Yeah. So we started out here and we dilated in. So it multiplied. You would end up taking and subtracting. You'd multiply the x coordinate by half after you subtracted it and then added back in. Well, like I said, we're going to do it here. I'm going to make things more complicated trying to speak, instead of just doing the problem. All right, so number 8. Give me 1 second. Keep me straight here. I'll have to get my notes. Okay. All right, so number 8. Triangle TRS has vertices of T. Let's see, let's just write this down. So T is -9, -3. Now, let's see, hold on. We're going to center our dilation at R. So R won't change. I'm going to put R and R prime are both going to be the same. And that's 0, 6. I could show you how you take that point and add and subtract it back in, but we don't have time in this video. If you want to see it in class, I can show you. All right, let's see. So, let me use different color here. Let's see. All right, so T, well, that's going to be 1/3. Your X comma Y is going to be, what's 1/3? Well, let's just do the problem. So, -1/3. So then it's X, which is -9 here for T, minus the X, or A. So this is your A, B, because that's where we're dilating. Our center of dilation is this point. So minus 0 plus 0. I messed that up. So let's go. We're going to go this way with it. 1/3 -3, the Y, minus 6 plus 6. That's this guy. All right, so -9 minus 0 is -9. -9 times 1/3, so your T prime is -3. All right, so -3 and -6 make -9. -9, let's see, hold on. Let me check my math here, hold on. That'd be -9, 1/3 of that. Okay, yeah. So -3 and -6 make -9 times 1/3 is -3. -3 plus +6 is +3. All right, so R stayed the same. Let me use a different pen. We'll do S and do a little better down here. So S was 6, -9. All right, so it's going to be 1/3. That was our K. X is 6 minus 0 plus 0. 1/3 Y, which is -9, minus B plus B. So we're going to write this above. So S prime. All right, so 6 minus 0 is 6. 1/3 of that is 2. 2 plus 0 is 2. -9, -6 make -15. 1/3 of -15 is -5. -5 plus +6 makes +1. So here's your S prime, T prime, and remember R was the same. Okay, so let me take this down here. And I'm gonna have to do it like this. Let me back out just a little. So we'll do the green first. That's gonna be our TRS. I'm just gonna make it, you can't see that, but it's green. You will be able to see the second one, that the orange one is, well, T prime, R prime, S prime there, up there. So T was -9, -3. R was 0, 6, and S was positive 6, and negative 9. So, not perfect. Now, so R and R prime are the same. T was negative 3, positive 3, 1, 2, 3. And then S was 2, positive 1. So, say we go here, here. All right, see, there we go. We dilated a third, so this is a third of this guy, and we did it with respect, or our center of dilation was point R, so up here, so everything shrunk in there. Hopefully, I know that's a lot of math, and it gets a little bit much, but hopefully that made sense to you guys. So let's scooch over here for number 9. And we'll do the same thing. We'll just say that our original is green and our new one is orange. And it's going to be centered at Y. So this will stay the same. Our scale factor is 2. So x comma y is going to be 2 times x minus a plus a. And then 2 times y minus b plus b. All right, so let's do this. Okay. So x, we know y is the same. So x is 3, negative 4. So it's going to be 2 times x, which is 3. So this is our a, b. Minus 6 plus 6. And then 2 times y, which was negative 4, minus b plus b. Okay. So 3, let's see, 3 minus 6 is negative 3. Negative 3 times 2 is negative 6 plus 6 is 0. So let's take this over here and say our x prime, our first is 0. Over here, negative 4, negative 5 makes negative 9. Negative 9 times 2 is negative 18. Plus 5 makes negative 13. Okay. Well, let's just do this. And so y stays the same. Z. Whoops. 8 comma negative 2. So it's 2 times 8 minus 5 plus 5. 2 times negative 2 minus 5 plus 5. So 8 minus 5 is 3. 3 times 2 is 6 plus 5 is 11. So z prime 11. Negative 2, negative 5 make negative 7. Times 2 is negative 14. Plus 5 is negative 9. Let's see. Okay, yeah, 11, 9. All right. So we'll start with y. It's going to be the same for both. So 6, 5. Now, our x originally was 3, -4. And our z was 8, -2. So here, ugh, that was terrible. Okay, why I am a math teacher and not an artist. Okay, so there's your pre-image. Now let's get our image. So we had 0, 13. 0, -13. So this guy's going to go 11, 12, 13. So 0, -13. Way off the board. There is y because it stays the same. And z is 11. So 1 over here. -9. Oh, that's going to confuse me in a minute. So we'll just try to stay down that line. Way out here. God, this looks terrible. Yeah, well, this is what happens when you don't do what you're supposed to here. So it's 3, -4. So yeah, this guy went. I think my math may be wrong on that one. We'll look at that later. So instead of putting a comment, yeah, just this might be wrong. Something may be wrong with this or in this coordinate. I'll come back to that. All right, moving on to page 4. So let's back up a little. Let's go back in. All right, page 4. Number 12 on the left. Triangle A prime, B prime, C prime is the image of ABC after a dilation. Describe the dilation, then write the coordinate rule to represent it. All right, so corresponding sides. That's going to be AB and A prime, B prime. So if we look at our coordinates, A is -1, -2, -3. So 0, -3. A prime is 0, -3, -4, -5, -6, -9. So, whoops, 0, -9. And B is 0, 2, yeah, 0, 2. I wrote this wrong. Yeah, I'm sitting here. -9, 0. Sorry, that last one got me thinking. -3, 0. Yeah, that's 0, 2. And then this is 0, 1, 2, 3, 4, 5, 6. Excuse me. So, our points, if you notice, so A to A prime, if you go 3 times -3, you get -9. If you go 3 times 2, you get 6. So you can tell that the scale factor is 3. You could also use the distance formula, and that would give you, if we use the distance formula, you would get for AB, it's the square root of 13. And for A prime, B prime, it would be the square root of 117. And when you do the math, it'll still give you a scale factor of 3. And let's see. So scale factor there, write the coordinate rule. Coordinate rule is x comma y is kx comma ky. All right, 13. DEF is the image of D prime, E prime, F prime is the image of DEF after a dilation. Describe the dilation. Write the coordinate rule. So this and this. We actually, if you count, 1, 2, 3, 4, 5, 6. So, if we go out, so it's 6 out, and if you count from here, it's 1, 2. So the whole thing was this was 2, and now it's 6. Well, actually, excuse me, we're going from 2, so we went from 6 to 2. God, I wrote it wrong. So 6 to 2 is 3. Or, well, actually, I wrote that wrong. It's old, new to old. So new to old, 1/3. So our scale factor is 1/3, and that's a reduction. And I think what it may have wanted with the coordinate rule, x comma y here is going to be 1/3 x comma 1/3 y. All right, let's scooch down. Number 14, and then finally number 15 will finish off this topic a little longer. I have to keep this in mind for class tomorrow. All right, so rectangle. Oops. Rectangle WXYZ has vertices and it gives the coordinates. Graph the WXYZ and its image after a rotation 90 degrees clockwise about the origin and a dilation centered at the origin. Scale factor of 1/3. So we're centered at the origin, so we don't have to do anything special here except multiply our XY by that after this rotation. All right, so to get this guy set up, it's going to be, so this rotation 90 degrees clockwise, that's the same as 270 counterclockwise. Give me just a moment. Let's see. It's y negative x. So x comma y. It's going to be y comma negative x for this rotation. And then that x comma y is going to be 1/3 x comma 1/3 y. All right, so W. Let's start with W. It's at 3/6. X, let's see, centered at the origin. We're just going to rotate. Okay. All right, so X is 9/6. Y is 9/3. And Z is 3/3. All right, so Y comes up front. So this is going to be, let me just do this. This is going to be W prime. So the Y goes up front and the X becomes negative. So -3. X, so the Y comes up front. The X becomes negative X. For Y, the Y goes up front. The negative X. And then Z prime. These are both the same, but the Y goes up front and the X goes to the back, becomes negative. I think I will do it again this way. Prime prime. Oops, X prime prime, Y prime prime, Z prime prime. So all right, so 6 divided by 3, because 1/3, or times 1/3, whichever you want to do, but 1/3 of 6 is 2. 1/3 of a negative 3 is 1. 1/3 of 6 is 2. 1/3 of negative 9 is -3. 1/3 of 3 is 1. 1/3 of 9 is -3. 1/3 of 3 is 1. 1/3 of -3 is -1. So now let's graph everybody. Got an extra color here, so we're going to start with green. We'll go to orange, and then we'll finish, I guess, in blue. So 3, 6, 9, 6, 9, 3, 3, 3. So rectangle, and these are all on the line here. So now we're going to rotate it 90 degrees counterclockwise, so it should end up down here. So +6, -3, Positive 6, negative 9. Positive 3, negative 9, and negative 3. Okay. This happy little accident. Sorry. Just joking. Okay. Man, this thing's going to be terrible. Well, actually, let's try this other pencil. Okay. Now, so after we rotated from here to here, then the dilation center at the origin, so it's going to shrink in here, or shrink toward the origin, actually. So 2, negative 1, 2, negative 3, 1, negative 3, and 1, negative 1. Okay, so see how we rotated, and notice it went from the long sides this way to the long sides that way down here. Also looks better down here, but anyway, and then it shrunk. It reduced down a third. All right, number 15. It's going to work. Same thing. Let's see. Nope, this time we're centered at K. So K is our center of dilation. We're going to reflect in line y equals negative 3, and our K is 2. We're enlarging by 2. So a lot of stuff going on here. So K won't change. Let's see. Well, it won't change until we reflect. Now, let me see. So if we're reflecting at line y equals negative 3, that's this line. I'm going to make it brown. So you guys know what the brown line is. That's that line. So we're going to graph it in its image after a dilation and a reflection. So first we're going to get bigger, and then we're going to reflect over. So we have J, negative 2, 1. K isn't going to change. And then L. Well, it won't change till we reflect. 1, negative 4. All right, so dilation, that's x comma y. Going to be kx, ky. And then to reflect, we're going to see how many over we are, and we're just going to reflect. So, negative 2, positive 1 for scale factor of 2. So J prime is going to be negative 2 times 2 is negative 4, and 2 times 2 is 2. K prime, let me see. Oh yeah, so it's centered. No, wait a minute. Got ahead of myself. Shoot. Let's see. Well, all right. So yeah, it won't be this. It will be, so this is our AB. Because, so we got to go, it's going to be K times X minus A plus A, and then K times Y minus B plus B. So scratch that out. We know this stays the same. So negative 2, well, first it's 2 times x is negative 2 minus a was 2, plus a, 2 times b, which is 1, minus the b, I'm sorry, y was 1 minus b was 0, sorry for the confusion. So j prime. Luckily that helps us. So -2 and -2 make -4. 2 times -4 is -8. -8 plus 2, +2 is -6. 1 minus 0 is 1. Plus 0 still 1. Times 2 is 2. So L. So 2 times x is 1 minus a was 2 plus 2. 2 times -4 minus 0 plus 0. So L prime. 1 minus 2 is -1 times 2 is -2 plus 2 is 0. -4 minus 0 is 0 plus 0 is still -4 times 2 is -8. Let me see. So yeah, let's see, K. All right, now let me draw this. So we will start with the green. So -2, +1, 2, 0, and then 1, -4. All right, so we started out there. Now we got to blow it up. So the J, and notice we're going to cross this line. So wherever it is here is going to be here. That triangle is going to be sitting kind of strange. All right, so J, -6, +2, 1, 2. K is the same. L is 0, -8. So that's all right. So we blew up from the green to the orange, and now we're going to reflect over in the blue here. So we're going to start with our J prime. So this is K didn't move, and this is L prime. Even though it didn't move, we're still going to change them all to prime at the end. So if we're reflecting in this line, notice this guy is 1, 2, 3 over. So we're going to go 1, 2, 3 over here. So J prime becomes 0, +2. All right. So K is 1, 2, 3, 4, 5 over. So we're going to go 1, 2, 3, 4, 5 over. It's still on the axis, so it goes from 2, 0 to -8, 0. Okay, and then L, 1 second. Just checking. One thing, sorry guys. All right. L is, so, where was L? L was 0, -8, so it's 1, 2, 3 over, so 1, 2, 3. I'm just going to touch it there. This is L prime, which is going to be -6, -8. Whoops. All right, now let's try to draw. Okay, so notice we expanded here, or enlarged here, and then we reflected over here. It's going to be it for this evening. Sorry for such a long video, guys. It's a lot to cover, a lot of math. If you got any questions, let me know in class. Until next time, have a great night.